Alright, so these are different. How are these different? There's an equal sign. Perfect. So let me make a big deal of that. There's an equal sign here. There's an equal sign here. Okay? Now, what's confusing for students all the time is they go back and they go, oh, that looks like these. They're adding and subtracting fractions. Huh. And what's the first thing that pops into your mind when you add and subtract fractions? Get a common denominator. Okay? So if you're adding and subtracting fractions like these, yes, you will get a common denominator. And do you think your answer is going to be a fraction?
Yeah.
Probably, huh? With a bunch of variables and numbers and stuff. Now, what's different in an equation is I can get rid of the fractions. But the students see that and they go, that is so cool. I think I'll get rid of fractions all the time, even for problems like that. Okay? You have to distinguish one from the other. Otherwise, you will fail the next quiz and the next test. Fail. Because you're going to miss half of the problems. And half is 50%, and 50% is fail.
Half the knowledge.
Okay? So, notice no equal signs. Equal signs. That's huge. Small, but huge. Now, this is going to be kind of like what we did for complex fractions. We got rid of the fractions, kinda, didn't we? Okay. So, here you go. In Algebra 1, were you taught that you can do the same thing to both sides of an equation? Yes? So I'm going to multiply both sides by 4 and x plus 1. 4 and x plus 1. But that's if I have an equation. That's huge. Alright? Now, here's what happens. When I multiply this times this, what's gone? The 4's. And what's left? X plus 1 times 4x plus 3. And I lost what sign that was. Okay. And then minus. Then when I multiply, I have to distribute, right? I have to also multiply here. So I multiply this same thing on the outside by this guy, but this time, who's gone? X plus 1, and the 4 and the 2x are left. So there's the 4, and there's the 2x. Hey, hang on, let me just finish. Equals. And then on the right side, do you see 4? Do you see x? Well, that's 4x. And it's going to multiply by the x plus 1 eventually. And what don't you see in this step? You don't see fractions. So in equations, we can clear fractions. So then I'm going to take this guy and clean it up. What's this? 4x squared. You guys have a good memory? Let's find out. What's this? Hold that thought. What's this? What's 4x and 3x? Good memory. And what's this? 3. And then, what do I get here? Minus 8x. And what do I get here?
4x squared plus 4x.
Good job. Okay, here we go. We're going to subtract 4x squared from both sides. Okay? And then, what's 7x minus 8x? Negative x plus 3 equals 4x. How did I get the x's to the right? Add x to both sides. And so I have what on the left? 3. What on the right? 5x. And then to get x by its lonesome, what do I do?
Divide both sides by 5.
Divide both sides by 5, and I get 5 over 3, right?
No, you had 3.
No. Gotcha. People do that all the time. I don't know why, but I want to make sure you're not one of them. Now, the A students are worried because they look at this fraction and they go, well, it's got a variable in the denominator. There's always a chance that the x I find is a bad number. Okay? What x value is going to be bad in this problem? Negative 1. Because what's negative 1 plus 1? 0 in the denominator. We were lucky it wasn't. But I want you to be good because you can't always be lucky. And so what you do is you check for answers that don't work. So now those of you that want to become A students are now thinking, I'm going to be better than the A students. I'm going to check for it at the beginning. And so they look at this problem and they go, x better not be what?
Negative 1.
So what they do is they write a little note to themselves. X better not be negative 1. Instead of waiting till the end and forgetting, they figure, let's deal with it at the beginning, then I won't forget as often.
If it is, what happens?
Okay?
It can't be.
Then, if I find out that I work, and all I get is x equals negative 1, and it can't be that, well, goodbye, answer I found. Now I don't have an answer. I don't have an answer. Nothing works. Unless you want to go back and try it again. But then all you're going to find is the same thing. Hello. So, in B, what's the common denominator that contains everything I want to get rid of? 2 and the x plus 1. Would you want to distribute that? No, because you want that. In fact, factored form is so much better, right?
So you would put no solution?
If this happened, yeah. Okay, here we go with the next one. So then I distribute here to here. Who's gone? 2. Who's left? X plus 1 with the 2x minus 3. What's the sign between the groups? Plus. Who's gone in the green? If this one's gone, what's left? 2 times 5x. Good. And then in the purple, who's gone? Nobody, right? Who's left?
2x.
The 2, the x, and the x plus 1. Okay. Now, I'm going to have you start here and solve it on your own. Okay, so what do I get here? 2x squared. What do I get here?
0.
2x, hold that thought. What do I get here?
0.
Negative 3x.
Negative 3x plus 2x is negative 1x.
Oh shoot, it's all wrong.
And 1 times negative 3 is?
Negative
Negative 3. And then plus, what's this? 10x. And what do I get here?
9x minus
2x squared, what?
Another 3 over 7.
Plus what? 2x, okay, good. Goodbye, goodbye. Subtracting 2x from both sides. I subtracted 2x squared from both sides. I did not cancel. Subtracting makes a 0. 0 doesn't have to be there, right? Okay, negative 1x plus 10x. 9x. So then I'll subtract 9x from both sides. Who's left on the left?
Negative 3.
Who do we have on the right? Negative 7 over x. I am going to divide both sides by
7.
negative 7 because what's negative 7 over negative 7?
X.
1. 1 disappears sometimes when you're multiplying. 0 disappears sometimes when you're adding and subtracting. 0 and 1 don't mean the same thing, do they? But you call that canceling all the time. No. X equals 3/7. And as long as x doesn't equal
1. Negative 1.
negative 1, we're happy. And if we're happy, we're happy. Okay, in C, who is the common denominator? X minus 4. X minus 4. When I multiply here, who's left? X period equals. When I multiply here, who's left? 4. Plus, when I multiply here, nothing disappears, right? I have the 4 left and the x minus 4. Here we go. Alright, if I keep going, I get x equals 4 plus what? 4x minus 16. I think I'm going to subtract 4x on both sides. And what do I have on the left?
Negative 3x.
Negative 3x, good. What do I have on the right?
Negative 12.
Negative 12, okay. And then what do I do?
Divide by negative 3.
Negative 3, negative 3.
And x equals 4. And we're done, right?
No,
No, it
solution.
can't equal 4.
Do I have some A students in this class? What was that again? What?
Can't be 4.
Oh, why not?
Because they're going to get 0.
Oh, goodbye. Wait a minute. That's not an answer I found.
That's a you problem.
No,
There was no.
I have no answers that I used. You threw away the one I found. What does that mean?
no,
That means
No
it's
sense.
not
No,
a
no.
solution.
Can you spell no solution?
No.
You can't. I know, the solution is a long word for you, right? That's true. If you write this out, you get perfect score. If you write this out, that's what it means. Either one's fine. Okay?